YouTube, it's your girl Yaya. Today's video is on motion. Motion is the process of a moving object or an object being moved. Motion includes the change of speed and direction. This video will describe motion by its concepts: distance, displacement, speed, velocity, and acceleration. Distance being our first concept brings us right into the video. Distance is the length of a path between 2 points, like from starting point to finishing point. Meaning, if I walk 20 feet across the street, my distance would be 20 feet. Now, for instance, direction would be the way in which one is walking, so like north, east, south, or west. Displacement is our second concept. Displacement is the measure of distance and direction. In other words, displacement is how far an object is from starting point to ending point using a straight line. Now I'm going to show a visual representation of what displacement would look like when you need to find it. So each block represents 1 centimeter, and I will have my distances, which these are our distances, the 4, 8, 2, 3, and 2. And we also have our directions, north, east, south, north, and west. All right. So now I'm going to start drawing my displacement. So the first line would be 4 blocks north. And I am still using the centimeter side, but I'm starting in the middle of my page to get an even distribution. So we just did the 4 blocks north. Now we will be doing 8 blocks east. Now after 8 blocks east, we have 2 blocks south. Right after the 2 blocks south, we have 3 blocks back north. And following the 3 blocks north, we have 3 blocks going west. So now I'm just putting points over each stopping mark. So at the end of each distance, I'm putting a point. To find the displacement, we will use a straight line from the starting point to the ending point. I was just showing you what our blocks were, so it'll make sense at the end, but each block represents 1 centimeter. The dotted line represents the displacement. The next step of finding displacement is measuring from the starting point to the ending point using a straight line. So I'm counting the centimeters of the length of the displacement. I got 6.5 centimeters, so that will be your displacement. Alright, so our next topic would be speed. Average speed is the rate at which an object covers a certain amount of distance in comparison to its time. I will demonstrate how fast my leopard geckos can walk 4 feet within their time, how long it takes to travel the 4 feet, because with the geckos, they might stop or something. So I will put the acceleration, but first I'm going to tell you about acceleration. Acceleration is the rate at which an object's velocity changes. Acceleration is defined by Newton's second law. Newton's second law is the acceleration of an object is equal to the net force acting upon it divided by the object's mass. So let's get into the formulas. The formula for acceleration is net force over mass divided by mass. The formula for average speed is distance over time. So now I'm going to go get my geckos and I'm going to measure out the 4 feet and get a timer to get it cracking. Okay, I'm back with both of my geckos now, if you can see them. I'll try to focus the camera. This is Athena and this is Zeus. And now we're going to have them walk 4 feet across the floor and see how fast they get there. Okay, from the water bottle to the Carmex is 4 feet. I will have my geckos walk this distance and see how long it takes them using the average speed and acceleration formulas. Zeus is our first contestant. I will do him first. So let's see. So here we have both times from both geckos. There's Zeus, he took 11.7 seconds to walk 4 feet, and Athena took 22.6 feet. 6 seconds, I'm sorry. So the formula for speed is velocity equals distance over time, which speed and velocity do share the same formula that I'll show you later in the video. Acceleration is final velocity minus initial velocity, which would be the starting point, divided by time. So in order to find the average speed of both geckos, we'll first have to start off with writing our formula. And then we'll put our distance, 4 feet, over the time, which is 11.7 seconds. And that, so let's do the math. We'll do, okay, I want to go get a calculator, but here are our average speeds for Zeus and Athena. This is for Athena, and this is for Zeus. And this is millimeters per second because I did measure it in feet. So let's say centimeters per second. I'm not exactly sure how I would measure feet into this. But to convert acceleration with using these times, we'll have to use this formula. So for Zeus, we'll put his final velocity was 0 minus initial. His velocity was 341. So we'll put 0.341 over 11.7 seconds. And then Athena's would be 0 minus 0.176 over 22.6. So Zeus Zeus's acceleration would be 0 minus 0.341 divided by 11.7 equals negative 0.029. And Athena would be 0 minus 0.176 divided by 22.6 equals 0. This is how you would find your acceleration, and this would be how you find your average speed. And now for Athena. She's our second trier. Alrighty. Say bye, Athena. On to our next topic, velocity. Velocity is the sum of speed and direction. It also correlates with frame of reference. Frame of reference is the perspective, your perspective on a moving object. The way these two correlate with each other would be the change in position. So please like and subscribe the video and share with your friends. Thank you. I hope you enjoy. On the sidewalk would be a frame of reference, because to the jogger, the person in the car is moving. But to the person in the car, the jogger is the one moving, even though they're in a moving car. Speed and velocity also do share the same formula. So it would be distance over time. We're done with topics for the video.